Black box testing. Now, black box testing, the user is not aware of what is inside. He will only check for the functionality. So this is the technique for software testing. This is the technique of test cases design, which examine the functionality. For example, test 10 functionalities are there. He'll test for 10 functionality. That is what these functions are doing, whether they are working perfectly or not. You are not aware of internal structure or coding, as unlike in white box testing it was done. You were using the basis path, you were using the the cyclomatic complexity, and then all the branching, all the paths have to be covered. That is how we design the test cases for the white box. So black box testing is also called as behavioral testing, functional testing, and the main focus is on the functional requirement of the software. How does it work? Whether all these functions are being executed, they are working fine. Please remember, black box testing is complementary to the white box testing because they both uncover different classes of error, different kinds of error. Okay, I'll tell you what kind of error the black box testing will generate. Let me add one more thing. This black box testing is always done after the white box testing. If you combine these two, there will be another testing called as gray box testing. Again, telling different kinds of error, classes of error they find. So as I was telling, BB or black box testing, the error can be incorrect or missing functions. For example, you just have 8 functions, 10 are given to you. The interfacing errors, whenever we combine modules, there will be some integration problem, and these integration or interfacing errors we have to finalize, we have to see. Now, errors in the data structures or the external database access, because whenever we are sending or receiving data from some external system or a subsystem, there can be some errors, there can be some problems, there can be some behavior or performance issues. For example, you are doing file transfer, you are being told 10 millisecond will take for say 100 MB, but what you are witnessing is you are getting say time as 100 millisecond for the same data. There may be error. Initialization and termination error. How does a work start? How does a work end? How does a function starts and it ends? That means behavior. That kind of error can be generated by the black box testing. So the black box testing is generally applied after all the testing is over. So because this black box testing is not aware of control structure, its attention is totally on the information domain, the functional domain. So we have different kinds of black box testing and we'll be discussing few of them. So black box testing can be done using the boundary value analysis. It can be orthogonal array testing, equivalence partitioning, graph based testing, fuzz testing, and state transition testing, all pair testing. Boundary value analysis, orthogonal, equivalence, graph, these are we are going to take. Okay, I'm just saying black box testing are these. You may choose any of them or few of them depending upon your application. So black box testing are designed to answer how is the functional validity tested, how are system behavior and performance being tested, what classes of input will make a good test cases, is the system particularly sensitive to certain input values. For example, we can test for certain sensitivity testing. How are the boundaries of a data class isolated? We can use the boundary value analysis for this. What data rates and data volumes can the system tolerate? So stress testing, load testing, performance testing we can apply here. All these I'm talking about comes under system testing also. What effect will specific combination of data have a system on this system operation? Multiple combinations, some data can affect differently, some may affect differently. Because scanning, enumeration and penetration, these are the main thing for black box testing. We are not aware of, we don't want to go inside the system.